Good morning, students. Let us know about instrument transformers. Previous classes we have discussed what is the importance of instrument transformers, where we are going to use these instrument transformers in our electric field. On continuation of this instrument transformers, we have learned the current transformer. At a glance, you can see what is a current transformer. A current transformer is used to measure the current of another circuit which has a very large amount of the current that can be measured with the help of our available small meter. The CTs are used worldwide to monitor high voltage lines across the national power grids. A CT is designed to produce an alternating current in its secondary winding that is proportional to the current that is measuring in its primary. A current transformer also consists of two windings, namely primary and secondary, as shown in the figure. Current transformer is basically a step-up transformer. It works on the principles of primary MMF and equal to the secondary MMF. Okay, so we have seen. At the same time, it works on the same principles as that of ordinary two winding power transformer. The low range ammeter, for example 0 to 5 amperes, is connected in secondary side of the current transformer to measure the current in the primary side. The ammeter is calibrated to read the high current, or it will be provided with a multiplying factor. So, what is the meaning here? So, let us see this one. Now, that means here what of the CT, that is there is a primary current which is flowing, that may be, for example, it is a towers, now this current, I want to know that what is the amount of current I want to know. So, this current to be measured with help of our CT. Already we have seen its construction of CT. The CT is nothing but it has a secondary and is connected to our ammeter here, and this transmission line acts as a primary, that is maybe I1, and it has a turns, single turn, we can say the N1, and this secondary has number of turns, that is the N2, and the current is flowing in this one is the I2 current. The primary MMF, that is equal to N1 I1 is equal to N2 I2 of CT. That is equal to MMF, magnetomotive force of primary, is equal to MMF of secondary. So, here difference of this one, sometimes it is changes these values. The difference current will flows, the MMF produces the EMF, that is flow, the current is flowing through the ammeter. Okay, the flux produced by this MMF is nearly equal to this flux. So, here what will happen, this flux produced in the secondary and this one, sometimes this flux produced by phi 1 is greater than the phi 2. So, resultant flux will produce the corresponding EMF. That EMF produce the current, and the current is flowing through this one. That is equal to the primary current and secondary, the CT ratio. We are going to the CT ratio. What is the CT ratio? The CT ratio is equal to so for example, the current is equal flowing is for example 100 amperes. Then the CT secondary current, how much current is flowing here? So that is equal 100:1 ampere. 1 ampere. That means whenever the current is flowing, the conductor is 100 amperes and the current is flowing through the secondary is 1 ampere. So correspondingly induces the current is step down, voltage is step up. Okay. So this is the current. So what this is the current ammeter? That means once the current is flowing through this ammeter 1 ampere, it indicates the full scale deflection. From this one to this one, full scale deflection. Whenever the current is flowing from 0 to 1 ampere, it shows the full scale deflection. Suppose the current in this case is 0.5 amperes. That means it indicates the middle of the calibrated scale, the pointer will shows, that indicates some value. If the current is 0.1, it indicates this value. So such a way that we are going to calibrate this ammeter corresponding to the primary current. Okay. So sometimes we can tell what is the calibration. For example, I don't want any multiplication, then simply whatever this ammeter is a pointer, the calibrated scale here is for example 10 amps, 20 amps, dash 100 amps, I can calibrate it. When the current is secondary current 1 ampere, 0.1 ampere flows, it shows 10 amperes. If it shows 0.2 amperes flows, then it shows 20 amperes. And 0.3 amperes, it shows 30 amperes. If 1 ampere flows, it will be 100 amperes. So whatever the reading shown by this pointer on the calibrated scale is the current which is flowing on the primary side only. But actually, what is the current flowing in this one? 0.1, 0.2, 0.3 amperes only, less current amperes. That's such a way that high current is measured in terms of by using this meter calibrated such a way that. Sometimes what will happen if I don't want the values placed in the 10, 20, 30, 100. So I can use the same 0.1, 0.2, 0.3, same current, whatever the current is coming here. So here what is the current here? So what is the CT ratio? So 100:1. Now based on the same CT ratio, whatever the current is comes, 0.1 is 0.1, 0.2, 0.2, 0.3, 0.3, so up to 1. So whatever the value indicated by the pointer into MF, what is the MF into? We are going to multiply with 1000. MF is equal 1000. Okay. So 1000 into 0.1. So what is the value? So that is going to the 100 amperes. No. So I want the what is the current here? Multiplication 0.1 indicates the 10 amperes. No. So I want so only 100. You can say the MF is equal to 100 because the 0.1 into 100. So we are going to get that 10 amperes. So that is a 10 amperes will flows. So multiply with 100. So at last 1 into 100 amperes, maximum current is 100 amperes. Okay. Such a way that, so whether you are going to use the direct ammeter or you can use the fraction of ammeter into MF, you are going to get the what is the current in the line. Okay. So we have seen this. Now you can see this is the one current transformer used in our 33 kV lines, where it has the one chamber. Okay, this is a chamber. What it contains? It contains oil tank. So to cool the winding, oil indicators you can see here, and this is the insulation, the porcelain insulation, and here place the base. Okay, so what is happened here, the P1 and P2, these are two terminals, P1 and P2, two input and output terminals of this one. So what it contains, actually this is the one conductor P1 and P2, and here the secondary comes here, that is taken this outside. Okay, this is the placed in a tank, oil tank. Okay, placed in a oil tank. Then the current is flows. Whatever the primary current flows, corresponding the current flows in the secondary. Okay, so this is indicates one terminal and this is another terminal. Just you can see it. And this is placed connected to the taken out the outside, and this is the insulation, porcelain insulation, and this is the base. From this one you are going to use. Sometimes we can you can use two secondaries also. Sometimes you can take the another secondary also. So that means 100:1:1. That means here 100 is the primary, 2 are the secondaries. One can be used for measuring purpose and another used for the protection purpose. Okay, protection purpose. Now you can practically see the how the CT is placed in 33 kV line. Okay, so nowadays we are using the optical current transform also, latest one. It will works based on the optical. So it has the sensors. It will measure the what is the current in flowing in the primary. Okay, so this is the one thing. Now in electrical point of view, this is a physical point of view. Physically, so what is outside? How the shape of this one physical? Now let us as electrical students, let us enter into the our inside. Then what is the basic principle? We have seen already. So basic principle is this is the one core. The primary is connected here, secondary is connected here, and based on the current is produce the flux in the core. The core is the flux is linked with this winding and correspondingly induces the EMF. Once closed circuit is closed, it flows the current. The corresponding current flows the ammeter. Ammeter indicates the values. Okay, so here what is the number of turns? That is equal to N1. What is the current here? I1. And here number of turns, that is equal to N2. And what is the current? That is equal to I2. So this is a MMF of primary, MMF secondary. Correspondingly, so it will induce us a EMF and corresponding the current will flows in the ammeter. So ammeter indicates the, it produces the deflecting torque and indicates the uncalibrated scale. Okay, so simple transformer, you can see the two winding transformer. So here is the one precautions you have to take it. This is the one switch is provided. If you want to take the ammeter for the maintenance purpose, at that time you have to short this secondary. Why? Otherwise you may get the electrical shock. Why? So we will see later. Now you can see this is a rectangular, and sometimes we can use a toroid also. So toroid, you can see the same thing. Here the conductor in which the current is flowing, I want to measure it. Then I can use, here is a toroid core, air core. So corresponding, this acts as a primary, it acts as a secondary, and on which, so there is a winding, corresponding the current indicates the flowing this one. Okay, this is another type of current transformer. So based on this one, in practical field, whether you are going with a single conductor, so here what is happened? So the conductor, this primary is simply is going to the outside, and sometimes we can the winding is a single turn, 2 turns and 3 turns also provided in the core material. So this is the primary. Then what will happen? So different applications having the different current ratings, CT ratios, then corresponding current also flows in this one. Okay, now you can see how this one placed. You can see here one loop, single loop, there is a one loop here, The CT ratio is 120:5 amperes. 120 into 5. When primary current 120 amperes flows, in secondary it induces a 5 amperes which is connected in ammeters. So you can see this is a one thing. Suppose this primary is twisted here 2 times, 2 loops. The CT ratio is same, but what will happen? The current which is 60/5 amperes. When 60 amperes flows, 5 amperes will flows. Turn ratio changed. Once suppose 3 turns, then what will happen? 40/5 amperes. CT ratio changed here. The correspondingly, when 40 amperes flows, 5 amperes produces. So based on the number of loops of primary winding. So these are the different types of CTs used in our electrical field, LT side only, low tension voltage only. So how can you use this for the HT? Then I can use for that is the current transformer in fields, in substation is a differential. Just previously we have seen on the slide. Okay. Now, what are the precautions you have to take while using the CT? The secondary of CT should be always short circuited, as we know that. So whenever the ammeter taken out for the repair or something maintenance purpose, the secondary of the CT should be 1. That means if this primary is going, this secondary that should be connected to the your ammeter. Once you are going to take the ammeter, but you have to short it, then you remove it. Okay. Otherwise, what will happen? So there is a severe dangerous problem may be occurred. So never open the secondary winding of the CT while primary winding is energized. The CT is always used with its primary winding connected in series with the line carrying current to be measured. So it is connected in this one. Okay. So this is the one precautions. What will happen, sir, if it is opened? Here I am going to open. Now it is connected here. Now the secondary is connected here. Okay. Now ammeter is opened. When current is flowing here, so what is happened? The current is flowing in this is equal, this is I1, this is the number of turns N1 and this N2, the current is equal to I2. So circuit is opened. For repair purpose, we taken the ammeter. What is happened? MMF of primary equal to MMF of N2. So whatever the flux produced by primary opposed by the flux produced by the phi 2. But what is the formula here? I1 N1 is equal to I2 N2. Now I2 becomes the 0 while circuit is opened. Then whatever the I1 N1 that is equal to MMF of primary is a very high. There is no opposition of flux to nullify the primary flux. Due to this one, what will, so very strong magnetic field developed in the core material. This strong magnetic field will forcefully makes the saturate the core. Once it is saturated, then what will happen? As per Faraday's laws of electromagnetic induction, there is a large amount of the pulse voltage EMF induced across the terminals, open terminals. At that condition, if you are trying to connect to the meter will burn. At the same time, if you are the person who is going to operate also may get the electrical shock. Why? So because high voltage generated at these two secondary terminals due to the open circuit. Okay, so that's why don't open the secondary terminals once the current is flowing in the primary. So if we want, sir, how can I if I remove this one, then before removing this one, short it. What will happen? The current may not be equal to 0 value. It produces its own flux, is always opposite this flux. Then whatever the flux in the core is limited. No dangerous voltage produced across the two terminals. Okay, so that is the one thing you remember. Now these are the CTs. You can see R phase, Y phase, B phase. CTs used in our substation for HT purpose. LT purpose, we have seen the coil, which is small CTs. For HT purpose, high tension purpose, we are going to use this type of the arrangements. Okay, it may be nearly 220 kV substation. You can see the size of the CTs. Okay, now these are the breakers, circuit breakers, SF circuit breakers, CBs. These are the CTs, and CB and CTs are the both friends. To operate this CB, and it has to give the signal permission to operate, whether it has to close or open with the help of our CTs and PTs. Okay, so we will see the PT also. Now there is one reason why the secondary winding of current transformer is always shorted. Just we have seen. Okay, so what is that one? So here you can see that with the diagram. Okay, we know that in a CT, so take the one figure. This is a line, transmission line. One line is going in this direction. Here is another tower. It's going. Okay, so this is a transmission line. I want to measure the current. Now I am going to connect my CT in this case. Here I connected the one ammeter. Okay, the CT ratio is the, for example, you can take this 100:1. Okay, 1 amps. 100:1 amps. So now let us, what will happen? Why the secondary op, this secondary op, this is the primary, this is the secondary. This is the primary. Primary act as a single conductor, secondary as a number of turns. We know that in CT the primary current is dependent on the load current or line current. As CT is connected in series with the line, this current in the line depend upon the load, how much load is connected in the end. The primary current of CT, assuming the constant line current, whether its current is equal to 100 amperes only, is constant irrespective of whether the secondary of CT is connected with burden or not. Normal, what will happen in transformer, the primary and secondary under no load condition, it will draw the current of I0. Then under no load condition, if it is connected to the load, it will draw the more current. That is, what is the current? The I2 current, that corresponding I2 dash current will come. Now what is the current now? This current is equal to, what will happen? So this current equaled, that is equal to I1. What is the I1? I1 is the vector sum of I0 plus I2 dash. So we have seen in transformers. That means the primary current depend upon the load current, but whereas in our CT it does not depend upon this load of CT secondary terminals. During the normal operation of CT, the primary and the secondary winding produces a MMF which by Lenz's law each other. So whatever the flux produced by MMF of here. So the flux produced by MMF, that is equal to phi 1, and this flux produced by the phi 2. The primary MMF, primary is a phi 1 and MMF of secondary is a phi 2. Okay, in normal condition it opposes each other. This flux is this direction, this flux is this direction, oppose each other. As the secondary MMF is slightly less than the primary MMF, then what will happen? The phi 1 is greater than the phi 2. The net MMF is small. So difference of phi 1 minus phi 2 is the resultant flux, that is the phi r is a very less. This net MMF is the working or magnetizing MMF of the core of the CT. So it is used to working magnetizing MMF of CT, the resultant this one. Now what has happened? Now in case the secondary winding is kept open, now I remove this one value. So I remove this value. Okay, then what will happen? Now in case the secondary winding is kept open, then secondary current will be 0. So current with I2 becomes to the 0. I2 becomes to the 0. Now no current is flowing because circuit is opened. Then MMF developed by the phi 2 is 0. Then whatever the phi 1 is more and more, only dominating the primary MMF only, because that is depend the N1 and I1. N1 is the number of turns in the primary, that is equal, and the N2, that is the I1 is the primary current, which is very large. This large MMF will produce a large flux in the core. So previously, so the MMF developed in the core is only phi r, that is a phi 1 minus phi 2. In this case, the phi 1, the flux produced in the core is itself due to the phi 1. This is a very large amount. So this large MMF will produce a large flux in the core and will saturate the core itself. Again, due to the large flux in the core, the flux linkage of the secondary winding will be large, which is will produce a large voltage across the secondary terminals. Because what will happen? Due to the flux, as per Faraday's laws of electromagnetic induction, it induces a large amount of the voltage. Because so here is the EMF induces a very high, that is equal E2. This is Faraday's laws of electromagnetic induction. This large voltage across the secondary terminals will be very dangerous and will lead to the insulation failure and will lead to failure of the total CT itself. Okay, so dear students, please remember these precautions whenever you are going to use a CT, don't open the terminals. This is a simple question and it will asked everywhere when you are going to any interviews, or it may be asked in any competitive exam. Okay, so what is the main? So once again I am going to explain, see it, two conditions. Once, what is the condition? Here, first condition, the primary current, this is the secondary, this one. These two terminals connected with, for example, one ammeter here. Ammeter terminals is connected with this one. Okay. Now, what is happened here? You can see the current is equal to I1, the terminals is equal to N1, simple, and the current in this case is equal to I2, number of turns is N2. Okay. Then what is the MMF? MMF of primary, this one equal to MMF of secondary, this one. As we know that MMF produced, that is equal to, we can say that the flux 1 is less greater than the flux 2. Secondary flux produced by this CT secondary is less than the MMF produced by the primary, because number of turns is less but current value is more. So difference of this one phi 1 minus phi 2, that is equal to phi r, resultant flux. This resultant flux links with the secondary coil once again and induces the EMF of E1, that is the induced EMF due to the resultant flux existed at the secondary. Okay, so that is due to this one. Once it is connected here, the ammeter will shows based on the CT ratio. If what will happen if I remove this one, same case, and our CT is now it is opened. What is happened? The current which is inside primary current is the same current, same number of turns, and the secondary number of turns is the same, but what is the current? Current I2 is equal to 0. The primary MMF, that is equal to I1 and N1 greater than I2 N2. Now in this case I2 becomes the 0. Then due to this one phi r, what will happen phi r? The resultant phi r equal to the phi 1 only. This is a very high value. This high flux links with the secondary of these turns. Then what will happen? It induces the EMF, and the core is also saturates. Then induced EMF in the terminal, that is equal to here, what is the EMF? E1 dash when terminals are opened. It is a very high voltage. Okay, this is a very high voltage. This high voltage will lead to failure of insulation of the CTs. CT has some winding, it has the enamel coating on the enamel coating insulation. Due to the high voltage insulation, the intensity electrostatic field, the failures the insulation, then total dead short circuit may be occurred. At the same time, that is dangerous to the operator who is going to connect the two terminals at that time. Okay, so this is the reasons why don't open the secondary. So what to do, sir? Then you connect the simply short it. If the short it, the I2 may not be 0. So that the MMF produced by the secondary is not 0. Then resultant will less amount of the flux, that may be here going to produce a less voltage that may not be dangerous to the operator. Okay, that's why don't open the secondary of the CT. This is a very important question. Please remember, dear students. Okay, now the outdoor and indoor, some you can see the some CTs used in our electrical field. Okay, so here you can see it. So these are the some outdoor high tension CTs. It is exposed to the atmosphere conditions and the high ranges. So one for the R phase and Y phase and B phase purpose, and single is R phase similar to the remaining phases. This is another type, this is another type. Outdoor type CTs for the high voltage purpose. For indoor type, so we are going to use, these are the different available CTs in our electrical field. Okay, so after knowing this, what is the CT? CT is the current transformer. How the CT is manufactured, how it will work, what is the principle, what are the precautions we have seen. Similarly, let us see our PT, remaining is a PT. CT and PT are the brothers, two brothers. Okay, CT and PT are the brother and sister. You can take it as a brother and sister. CT is the, you take as a sister, and PT is the brother. So now we have seen the what are the characteristics of CT. Okay, CT is a very dangerous. While dealing with sister, you have to be careful, because what is happened, you have to see it. Now let us see the what is the brother value, PT. Okay, what is the PT? Potential transformer. The potential transformer also consists of two windings, namely primary and secondary, as in the figure. So it has, what is the figure? So just it has a, you can see this is the core and is connected to the this one, and it is connected to this one. You are going to connect the voltmeter here, just like this one. Okay, it has a primary, it has a secondary, but step down voltage. Here is a, for example, 11,000 volts. Now we are going to get the 110 volts only. Okay, that is a step down, simple, the two winding transformer placed in a oil tank, similar to the CT. Okay, the potential transformer is basically a step down transformer. It works on the same principle as that of the ordinary transformer. The low range voltmeter is connected across the low voltage side of the transformer. The voltmeter is calibrated to read the high voltage, or it is provided with a multiplying factor similar to the CT. Okay, so what is that one? You can see here. So for example, I want to measure the voltage. Okay, so this is a one R phase, and this is another Y phase. I want to measure the what is the voltage between these two. For example, this line is equal, you can say the 132 kV line. I cannot use directly my voltmeter. I have the voltmeter, this is a voltmeter, I have this one. So this is some range. For example, 0 to, you can say is the range is only, for example, 110 volts. Okay, so 110 volts I cannot connect to the 132 kV. If I connected, it will burn. So what to do? So I am going to use one instrument, that is known as the PT. What is the PT? It has the primary winding, just like the transformer, and it is a less number of turns is connected here and here. So one, as in this one, more number of turns, this one is connected here and another is connected here. So it is connected two lines where we are going to measure the voltage. It's called the primary. So that is equal to, so that is a I1 and N1. Here is a I2 and N2, just like voltage transfer ratio. This is a step down voltage. That means 132 kV, 1000 volts to 110 volts. I am going to step down. So that is, we know that how we are going to step down already we know based on the number of turns. Okay, this small voltmeter I can use here. So what we will show? So based on this one, for example, I have the range. This for example this voltmeter itself. So here 0 to 250 volts voltmeter. Okay, 0 to 250 volt range. So based on the voltage, what is the CT ratio? So here I also going to the whenever the 132 kV in the line, then it indicates the full deflection. So I can indicate here. So what is the secondary current will comes? 132 kV by 110 volts, or we can say the 132 volts. Then whenever the 132 kV in the primary, it induces the voltage of 132. Once 132 volts comes, the deflection of this point is the maximum. In that case, I can show the 132 kV. I calibrated. Once the voltage is 0, then it indicates a 0 initial, that is a 0. Once the voltage is equal, for example, 100 kV, then it will show the one reading. So I can see so then voltage comes in the secondary is equal only. So what will happen? 100 volts. Then it will show the 100 kV. Such a way that I calibrated our voltmeter. So if 132 kV comes, it will show 132 kV. But what is the 132 volts comes? But I calibrated as a 132 kV. Okay. So these are the things. So directly you can take it, or so we can simply multiply it. Suppose it indicates the 132 full scale into, we can multiply with the kV. So into the 1000 we are going to get the what is this one. Similar to the what we have explained in CTs. Similarly here also this small voltmeter can be used to measure the high voltage range in the transmission lines. Okay. Now you can see the practically how this different type of the PTs available in our electrical field to measure the voltage, 11 kV voltage, 33 kV voltage, 66 kV voltage, 132 kV voltage and 220 kV voltage. So you can observe what is the difference between these voltages present in our electrical field. Okay. So you can see here these are the different voltage ranges. I want to measure the 11 kV is the working voltage. This is a 33 kV working voltage, but I designed for the 32 kV some extra. This is a 66 kV is available in India. I want to measure, so I am to use 72.5 kV, 132 kV purpose. So you can see once it is increasing, then automatically what will happen? These voltages are increases. Okay. Now you can see here. Now these are the based on the voltage insulation from the ground to the live, the insulation increased, you can observe here. Okay. So this is a diagram of CTs similar to the what we have studied just now. Okay. So what is this one? It is the primary, it is the secondary. The secondary is shorted to the ground. Okay. So calibrated is the 115 volts. And what is the primary voltage? That is the 4600 volts high voltage. Okay. Once we calibrated such a way that 4600 volts step down to 115 volts. Okay. So that is the high voltage is stepped down to the 115 volts. So based on this one, I calibrated my small voltmeter. It indicates this one. Here precaution. So because whatever the voltage induces, so that is given to the ground. Okay, similar to that one. Now you can see the another diagram also. What is this one? High voltage AC supply here given, and this is a load is connected. I want to know that what is the voltage across the phase and neutral single phase, for example. I connected with the transformer, our PT voltage transformer. So based on the number of turns, the step down to the voltmeter is connected here. Okay, so already you know. So let us see LT type, low tension type, how based on this principle, how these are the PTs are manufactured and used in for the different voltage purposes in LT line. Okay, so you can see the LT line, sometimes HT 11 kV also. That is the, we know that if the voltage increases, the insulation value should be increased. If the current increases, the cross section of the conductor should be increased. That is a basic fundamental. Okay. Now you can see the some medium, low and medium type PTs used in our industries. So these are the different types of PTs used to measure the voltage in high tension voltages. Okay. And suppose you may get, sir, how I can measure for a 400 kV voltage? So if this can be measured in 11 kV for example, or 33 kV. Okay, so now I want to use directly 400 kV or 765 kV AC voltage. Can I use this one? No. So I can use another type of the PTs similar to the CTs. You can see that also. So these are the PTs. Okay, the PTs are connected here. In this case, this is the R phase, Y phase, and B phase. It will measure the, we will take the, you can see the output terminals. So based on this output terminals, you will measure the, so that's why there is a switch. So R phase, Y phase, B phase connected switch. So we can see the voltage across the R, VRY indicates a 1 voltmeter, VYB indicates the voltage, the VBR indicates the voltage. By changing this knob in our panel board in our substation, we are going to measure the what is the voltage between these two, what is the voltage between these two, what is the voltage between these two. We will measure with the help of this one. Okay. Now, so we have seen CTs and PTs separately. How can we use this CT and PT to protect our system from faults, whether the faults may be symmetrical faults and unsymmetrical faults. How we are going to connect? So you have seen that. Okay. So what you have seen here, for example, this is a line. This is under R phase and this is the Y phase. Okay. So here R phase, Y phase, B phase. Okay. Suppose this is a sending station, this is the receiving station, load center. I want to measure, I want to protect this line. It's maybe distance may be suppose 100 kilometers. Then how to measure what is the current flowing in each line? I want to measure what is the voltage, line voltage between these lines. Now I am sending the voltage here, for example 132 kV. Whether I am going to get the here voltage, it may be 130 kV only. How we are going to find it? By connecting some instruments to measure voltage. So high tension voltages. So that's why at the same time I want to measure the voltage, I want to provide the protection also whenever any fault occurred in between the load center and generation. So how we are going to connect it? We will see. So now for example, you take the two phases. Here for example, you take the one R phase and is connected to the load, and here you are going to connect to the neutral. Okay, this is connected to the supply and this is a load. I want to know that how we are going to connect this one. Now in this case I am going to connect the CT and PT to measure what is the power. I want to connect the wattmeter also. Okay, I want to measure what is the current, what is the voltage, what is the power in the line, in HT lines. Okay, then I can connect here, you can see it. So for example, you take that, okay, you take this one, sorry. So you connect to the okay, this is the CT and these two terminals connected here, and you take the from this terminal you connect the and P. Okay, you can observe this is a CC coil, this is a CT, this is a PT. It will measure the voltage between these two. It will measure the current flowing through this line. Okay, so now I am going to connect here. What I am going to? So I can connect here one voltmeter. Now I am going to connect the one ammeter. Okay, such a way that I connect this one. So you can see it, voltmeter connected here with the PT, the CT is connected. Suppose I want to connect the one wattmeter, then how we are going to connect it? So wattmeter has the two terminals, one is the CC coil, another is the PC coil. Okay, so this is the terminals M and L, C, V. Just we have seen that this is a CC coil, this is a PC coil, pressure coil. As you know, now CC current coil you are going to connect it. Okay, you are going to connect the current coil. How to connect this current coil? So here the CC coil you have to connect in series. Okay, series you are going to connect in series. You take it outside. Now here you take this terminal and connect it, one terminal for this one and another terminal for this one. Okay, this series current is flowing to this one. Now PC, so here you take the another terminal. Now it is connected, the PC is connected to the here and is connected to the here. That means connected across this one, connected in series. So what will shows this one? So it will give the total. It's the wattmeter. CC coil measures the current flowing in this line. PC coil will give the voltage this one, correspondingly it will give the wattage, and here it will current will measure the current by the ammeter, and here voltmeter will measure the what is the voltage between these two lines. Okay, dear students, this is the simple circuit. Okay, such a way that we have to connect our CT and PT in our electrical field to measure the voltage and current. Sometimes we are going to use for the measurement of power also. Okay, so same line which is connected to the protective systems also. These are the how we are going to use CT and PT in commonly. Now let us differentiate between the CT and PT. Okay, so what is the differentiation? So this is what is the PT and what is the CT. What is the similarity? What is the dissimilarity? We can differentiate it. It is a very interesting. Okay, let us differentiate it. Okay, you can take this is the here connect it, sorry, CT and PT. Okay, first point, the primary winding current in CT is independent of the secondary winding current. So the current is equal I1 does not depend upon the load current, similar to the whereas in the two winding transformer the primary current depends upon the secondary current I2 dash. In this case I1 does not depend upon the I2 current. does not depend on the I2 current. Okay. The primary winding current in PT depends on the secondary circuit burden, but whereas in this case, so it works as a similar to the normal transformer. Okay, normal transformer because simple step down. And second point, in case of CT, it is connected in series with the one line and a small voltage exists across the terminals. However, CT carries the full line current. In this case, the current is the CT is connected in series. So that means whatever the current line current, that is equal current which is flowing through the load, maybe 50 amperes, maybe 500 amperes, or maybe 1000 amperes. Sometimes in short circuit condition, short circuit current may be 10,000 amps also. That will flows in series with the primary winding. So such a way that you have to design the CT. Okay. Now in PTs, full line voltage is impressed upon its terminals always. Whatever that one appears, that is appear in the secondary. That is one thing. Is connected in parallel. Okay. So here, third one. What is that one? The primary winding current and excitation of the CT vary over wide limits in the normal operation. The current, based on the current, what is the current is flowing in the line. The current may be suppose at that instant the load on the line is maybe 10 amperes. After few seconds it may be 15 amperes. After few seconds it may be 50 amperes. That is the current in the primary changes. Okay. In case of PT, it is under normal operating line voltage is nearly constant because in voltage is a constant, the load is changing. Current changes voltage, but it's a 130 kV line, it may be 130 kV plus or minus 5%. So 230 volts plus or minus 5%, the 10%. Okay, the voltage is parallel connected, parallel, the current is varied based on the load. But whereas the voltage is a constant, approximately constant. That is the third one. And another one is the fourth one is the CT may be thrown as a series transformer under virtual short circuit conditions. The PT may be considering as a parallel transformer with its secondary winding operating under open circuit condition. In PT we can open that also, but CT may not be open, this one, that is the one. So what is that one? The CT may be through as a series transformer under virtual short circuit conditions. So if we connected short circuited virtual conditions, whereas the PT considered as a parallel transformer with a secondary winding operating under open circuit conditions, here is short circuit condition. That is the fourth. Okay. Next, coming to the fifth one, the PT may be considered as a parallel transformer with the secondary winding is open. Okay. Next, fifth one is the secondary of the CT cannot be open during the maintenance. So that is why, what is a reason? Well, already secondary should always shorted. Okay. So the secondary of the PT can be open circuited maintenance purpose during the testing. We can open in secondary terminals. Okay. Simply it works as our simple transformer. Open circuit voltage appear across this one. But whereas the CT, so you know what is the problem. Next, sixth point. In case of CT, the primary current is independent of the secondary current. So primary current does not, that is the first point, does not depend on the secondary. So in case of PT, the primary current is dependent on the secondary current. So this it acts as a simple normal transformer. So the I1 is equal to I0 plus I2 dash, vector I2 dash. So this is a vector. In this case it depends. Okay. Now coming to the seventh point. It can be considered as a series transformer, as a series transformer, where it considers a parallel transformer. PT acts as a parallel transformer. Next, 8th point. By the help of the CT, 5 amperes ammeter can be measured high current as like 400 amperes. The 5 amperes meter can be used to measure the current of nearly 400 amperes with the help of our CT. So, whereas in this case, with the help of the 230 volts, ammeter can be used to measure the 11,000 volts with the help of our PT. Okay, the last one is the 9th one. So, we can use CT is used for current measurement purpose. It can be used for voltage measurement purpose. These are some difference between current transformer and potential transformers. Already we discussed everything this one, but here summarized. So, the CT is always connected in series, it acts as a series transformer, the CT of the secondary of the CT cannot be opened, okay, and the primary current, it does not depend on the secondary one, all things are already we have seen. Similarly, PT also, okay. These are some differences between the CT and PT, okay. Now, so these are what is this one? The primary winding. Already we have seen these all things. Okay, very simple. Now, applications of instrument transformers. So, these instruments where we are going to use it effectively. So, mainly it is used extend the range of instruments. So, small 5 amperes can be used to 400 amperes, small 230 volts we can use up to 11 kV. So, to extend the range of instruments, that is the first point. And second point, it provides the isolation from the high voltage in high voltage measurements. So, 132 kV is isolated from 130 kV to our small meters by using the PT. And at the same time, these two instruments can be used in case of protective circuits as a relay network. And it can be used also to reduce the measurement cost by using the low range meters. So, what will happen? So, low range, so 5 amperes and 230 volts can be used for measure the high range values, and used to provide the safety to the operating personnel. This is a very important. So, operator has to dare to take the readings, otherwise what will happen? He may be electric shock under different high voltage conditions. There is an induction effect, all things may be occurred. And several instruments can be operated from a single instrument transformer. So, by using this CT and PT, we can use the different ranges of 5 amperes, 10 amperes, different ranges can be used. Okay. So, one of the terminal of the secondary winding of the CT is earthed. Okay. One of the terminal of the secondary winding of a CT is earthed so as to protect the equipment and personnel in the vicinity in the event of insulation breakdown in the CT itself. If due to any problem, due to the insulation failures, the high stresses may be developed inside, that is dangerous to the operator. Hence, we are going to protect equipment and personnel in the vicinity in the event of insulation breakdown inside the CT. And in using CT for current measurement, one must know the ratio of primary current to the secondary current should be low. The current transformer is a low power transformer used to extend the range from this one. Okay, that should be very low. Okay, let us summarize what we have seen in this class. So, we have seen that what is the instrument transformer and what is the current transformer, how it connected in our electrical field, what is its operation, what are the precautions while using the current transformer, and what are the different shapes, sizes used in indoor and outdoor in our electrical field. Similarly, what is the potential transformer compared with a CT, and what is the construction, how it will works, and its operation also we have seen, and what are the different shapes and sizes of potential transformers used in indoor and outdoor of different voltage ranges. At the same time, how we are going to use the CTs and PTs to measure the power in an electrical system to connect the wattmeters and energy meters. At the same time, we have seen few main important differentiation between the CTs and PTs. After that, we have seen some few applications of these instrument transformers nowadays. Okay, now we have some idea what is instrument transformer, what are its applications, how to use CT, PT in our daily life. Okay, thank you dear students for listening my class.